It becomes a constant because they are asking how far does the car travel before it reaches the constant speed. So before it reaches the constant speed, it has traveled for 10 seconds. And how much distance basically it has traveled before reaching this 20 meter by second value. So this we know already the distance time graph, sorry, the speed time graph, the area is to be calculated to find out the distance. So here we can find out this area. Again, I do here the rough calculation. The area is nothing but here the area is nothing but half into base into height. So here half into the base of the graph is nothing but, you can see this is nothing but the right angle triangle, and here the base is 10 and the height is nothing but this is equal to 20 meter by second. So this height is on the y-axis, you can see this is 20. So the value, if you calculate this value, it is nothing but half into 20 into 10, that is nothing but 100 meter. So our value is nothing but 100 meters, that is option number C. Okay, all other answers are incorrect. So here it is nothing but the area under the line, that is nothing but 100 meter, option number C. Now the seventh question, a small steel ball is dropped from the low balcony. Ignoring air resistance, which statement describes its motion? So it falls with the constant acceleration, it falls with the constant speed, it falls with the decreasing speed, and it falls with the increasing acceleration. We know that whenever any body is moving freely uh, in the gravity, it has a constant value, and that is in the downward direction. So it has a constant acceleration, that is nothing but the correct answer. It falls with the constant speed. Whenever the object is falling down, okay, the speed basically increases. Okay, so the constant speed is not answer. Speed increases. Here, option number C, it falls with the decreasing speed. As I just told, the speed is increasing in the downward direction. In the upward direction, basically it decreases. Okay. Here D is given, it falls with the increasing acceleration. And acceleration should be constant, so it cannot be the answer. So option number A is the answer. Then question number 8, a man stands by a railway track. This man is over here. The train is given. A train traveling at 40 meters by second takes 2 seconds to pass the man. What is the length of the train? So you can see this train is traveling in this direction, and it is traveling with 40 meter by second speed, and it takes 2 seconds to pass the man. So you can consider only this initial point of uh, the initial point, and this is the final point of the train, and it starts with this initial point, and when it passes this man, then this point is also passing the man, and from this point to this point it takes about 2 seconds. That means if we calculate the distance covered or passed between these 2 points, okay, initial point and the final point, then that would be the length of this train. Okay, so to calculate that length, we have to use this formula. The speed is equal to distance by time. So here distance is nothing but the length of the train itself. The distance will be equal to the speed multiplied by time. Here the speed is given, that is nothing but 40 meter by second. So speed is 40. The time is given is nothing but 2. So here 40 multiplied by 2 is nothing but 80 meter. So our answer is nothing but the 80 meter. So option number D is the answer. Okay, so here the distance is nothing but the distance itself is the length of the train. This is nothing but the distance covered between passing while passing these 2 points, which is nothing but the initial point of the train and the final point of the train. Then question number 9. A snail moves along a ruler. It takes 20 seconds to move from Q to R. From Q, this is the point Q, and this is the point R. It takes 20 seconds to move from Q to R. What is the average speed from Q to R? So here the average speed is nothing but the total distance divided by total time. At speed is the distance divided by time, but whenever if they ask the average speed, it is nothing but the total distance divided by total time. So from Q to R, the time is already given, that's nothing but 20 seconds. But what is the distance traveled between the Q to R? You can see from P to R, the distance traveled is nothing but 12 centimeter. It started from 0 at point P and it covered 12 centimeter at R. So from P to R, it is 12 centimeter, and from P to Q, it is nothing but 2 centimeter. So the distance traveled between Q to R is nothing but this much distance. You can see this much distance, and this much distance is nothing but this 12 minus this 2, that is nothing but 10. Okay, so this QR is what? This is nothing but PR minus PQ. Okay, so PR is nothing but 12 and PQ is nothing but 2. So this much distance is nothing but 12 minus 2, that is 10. So here you can write this total distance is what? How much is 12 minus 2? 12 minus 2. Here I will put these numbers in bracket, divided by the total time taken, that's nothing but 20 seconds. So here in this case the journey is nothing but along the straight line only, so there is no difference between the distance and displacement. Whenever it is a straight line, the distance and displacement both are the same thing. Okay, so that's why we have calculated PR minus PQ, that is nothing but 10 by 20 centimeter by second is the value. Here option number B, you can see that it is nothing but 12 minus 2 divided by 20 centimeter by second. So this is nothing but our answer. So they are asking between Q to R, that's why this 12 by 20 cannot be answered. It is actually for PR. Okay, it is for distance PR, that is nothing but 12. This is given reverse way, this is 20 by 12, cannot be the answer, and here also it is given by 20 divided by 12 minus 2. 20 is basically the time, so it has to be in the denominator, so only option number B is the correct. And then our last question, question number 10. A racing car is fitted with an onboard computer. Every time the car passes the starting line, the computer records the distance traveled in next 2 seconds. Okay? Which state of the data shows that the car is increasing in the speed during the 2 seconds? Okay? So you can see this data is collected, the distance and the time, okay, and they are asking about when the car is increasing in the speed, okay, and the data is distance and time. So we know that if the distance and data is given, the slope of that data, okay, that is nothing but change in the distance divided by change in time is nothing but the speed. It is nothing but distance by time. So this rate should be increasing in order to get the increasing speed. So here you can see option number A, the time is going from 0 to 1, 1 to 2 seconds, and the distance is going from 0 to 100 and 100 to 200 meter. Okay, so you can see this distance between this 0 to 1, the change in the distance is nothing but this, that is, it is going from 0 to 100. So change is how much? This change is nothing but 100, that is 100 minus 0 is nothing but 100. And from 1 to 2 seconds, the change is nothing but this, that is from 100 to 200, so it will be 200 minus 100. So change in the distance is nothing but 100. So if the change in the distance is